Well, it's good to be with you again today. We are going to be wrapping up our chapter today. So let's go ahead and get organized with our advanced organizer. For your materials today, why don't you have on hand activity 1-6 and test 1, which will be coming up soon. And on our agenda, we have the Geographer's Corner. That's right at the end of our chapter. And we'll be taking a look at a hiking clip as well. Then we're going to do a little review from chapter 1. You'll be taking your test, and then after that, I'll be getting into the preview for chapter 2. So before we go any further, let's go ahead and start out with our chapter verse. And you can read this with me. For thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it. He created it not in vain. He formed it to be inhabited. I am the Lord, and there is none else. So we're going to start today by looking at our Geographer's Corner facet for the first time. It's our first one, and there's about one of these every chapter. And these facets are designed to show you about different tools that geographers use.
I must raise funds for my trip. Surely there are people who will want to invest. People who love exploration, discovery and adventure as I do. It's you! Just the one I was hoping to see. I have a fabulous expedition idea to tell you about. And I want to thank you for your generous support. I'm sure you'll want to have a share in this adventure too. I just need your investment to get me going, you know. And here's a portion of the area I'll be exploring. You can see here... Ach, Mensch, ich hab vergessen. I forgot the map. One moment, please. Wolfgang, I need the topographical map. Thank you. This topographical map depicts one area I'll be covering. These lines, no, they are not roads. They are something known as contour lines. They show the changes in elevation and are given at regular intervals. On this particular map, the contour lines are given at intervals of 20 feet, and the 100-foot intervals are marked off with numbers. The land obviously slopes upward here toward higher elevations. So where the lines are far apart, that means a more gentle slope. But where the lines are close together, the land rises steeply. Let's see what meridian is this on. Here on the right, what is the left? I pledge allegiance to... Yeah, it's on the right side along the 77th meridian. The left side here, near a longitude of 77 degrees, 2 minutes, 30 seconds west. It also has a variety of symbols. 2 exact altitude measurements are found as the benchmark, marked BM. Natural features like creeks and ponds are shown in blue. Green areas indicate woods. Other marks are highways, houses, and other buildings. Cemeteries are marked with a cross. Fantastic, isn't it? You can see why it's a perfect place for my next expedition.
Well, now that you've been introduced to the topographical map, let's take a look at one in your textbook. I believe it's on page 15. And we're going to see if we can learn to use that, answer some questions, and just get some practice with it. So on page 15, I'm kind of zoomed in a little bit so we can look at the first question. What is the altitude for the benchmark at Lawrence Corners? And that's what I've got a close-up on here, Lawrence Corners. And remember that benchmark is marked with B for bench and M for mark, and here you can see the altitude that our geographer referred to. So 1,287 feet. Okay, then also our second question, is Austin Hill the highest point on the map? Okay, so we want to find that and do some comparing. Austin Hill. Okay, so that's going to be a little further down here. And you can see right here 1,800, and then these are increments of 100 feet. On this one, they're regular intervals, so that'd be 1,900 feet. And then just take a second to scan the map. Or, I'm sorry, it's 20 feet intervals, so it'd be 1,820, 20-foot intervals, 1,820 feet. So kind of scan over the map and see if you can find an elevation higher than that. Okay, there is actually a higher one. The north edge of the map here, there's an area that reaches up to actually 1,900 feet. Let's see if we can locate that quickly. Right here, see right here on the edge, 1,900 feet. Okay, so that's not actually the highest. Then our third question, what creek flows through a wide valley and then empties into Mill Creek? That's our third question. So you're looking, okay, Mill Creek is right here, and then it's going to empty into Elk Run. Here's our Elk, and the Run is on down here. But this right here is the Elk Run. Elk Run flows and empties into Mill Creek. Okay? So that's how you can identify the creeks. Okay, then our question number 4. If 2 inches on the map equals 1 mile, how far is Austin Hill from Lawrence Corners? So you can use your pencil. Let's back up here just a little bit. You can use your pencil kind of instead of a ruler to measure that, or you can use a ruler if you want to. But you can, I'm just going to use my pencil here. And here's Lawrence Corners, and then here's Austin Hill. So it's about this far. All right, and 2 inches. Then you can compare your pencil mark to your ruler. Okay, it's going to be about, we can even just estimate here, you know, about 2.5 miles. But you could use a ruler or a string or use your pencil and measure it to find out distances, since there isn't a scale right here on the map. Okay, and then the 5th question, what is the latitude for points along the top of the map? Okay, remember that longitude and latitude are measured by degrees, and the degrees are broken down into minutes and seconds, just like they would be on a clock. So here we have the longitude marked up here, and here's 2 minutes 30 seconds, and if we come on over, it's 77 degrees and even, and then our latitude going this direction is 41 degrees 52 minutes 30 seconds. Now our thought question we want to look at together because it's a tough one, and I'll try to help you out with it a little bit. Can you see Austin Hill if you're standing in Lawrence Corners? And then try to draw a picture of what you would see when looking in that direction. Okay, so remember, here's Austin Hill, and here's Lawrence Corners up in the corner. What do you think? You could draw yourself a little sketch. Look at what's in between here. Look at the elevation. This is 1,820 feet. Lawrence Corners is around 1,287 feet. Well, it's a little tricky. If you want to spend a little bit of time, you probably need more time than I could give you to figure it out, but you could always pause the program and do some figuring. But I was thinking, well, if I'm about 1,200 feet and I'm looking up to about 820 feet, I should be able to see the ridge, the hill, Austin Hill. However, there is a ridge. It's lower than the hill, but it's high enough that it blocks our view of the hill from Lawrence Corners, and that's kind of a difficult one if you haven't used some of these maps a lot. But here's our Lawrence Corners, and then we have a ridge, and here's 1,700 feet, and that's going to block our view of the hill. And so if you did do a sketch of what it looks like, you'd have a ridge there, and 3 or 4 peaks probably, with the highest peak just left. When we're looking this direction, it looks like it's to the right of the center. But if we kind of turned our map, you know, we pretended to be looking here. It's going to be just to the left of the center, looking toward Austin Hill. Okay, so that gives you a little bit of exposure anyway to a topographical map, and you can see some of the features that are available on them. And now we're going to have the opportunity to see the practical use of a topographical map.
So we're headed to that mountaintop over there?
That's right. Now, let's look at this topographical map and figure out the easiest way to get there from here.
Hey, that doesn't even show us where we are. How are we going to be able to figure out how to get there if we can't see where we are or where we're headed?
Well, Tim, between the topographical map and our GPS, we can find out where we are and how we can get to our destination the quickest way.
GP what?
It's a global positioning system. Hold this for a second. This is going to pick up a satellite signal, and it'll show us on here what our exact coordinates are. Okay, here it comes. See there, it gives us our exact coordinates. Now we can find those coordinates here on this topographical map. All right, we should be, there we are, right there. And this is where we want to go.
Okay.
So, now the thing to do is study this for a second and just figure out the easiest way to get from here to there.
Well, I think this trail right here is going to be good enough, so I think I'm going to head out a while.
You don't want to use the map, Tim? It's really going to help us.
No, that's okay. I'll be fine, really.
Okay, not a good idea.
Oh, man, it sure is hard work. I wonder how Phil's gonna make it. This is a long trip. Well, I better keep moving. Oh, man. Oh.
Tim, you finally made it. Good job. Exhausted?
Oh, yes. Man, that was a long hike. No, wait a minute. I left before you. How'd you get here already?
Well, that's because you came from that direction. That's the steepest direction.
Yeah, but it's also straight on. How'd you come?
I came from over there. That's a lot less steep.
Well, how did you know that was going to be easier? It looks like longer way to me.
Tim, that's what the topo map shows you.
How's that?
Here's the point we climbed to. All these lines show changes in elevation. You came up over here where the lines are closest together. That means that the elevation changed more quickly, meaning that it's a steeper slope. Here, where the lines are further apart, that shows that it's a more gradual incline. It's more of a slope, not so steep. And that's where I came up. Oh, come here. I want to show you this view that I found. It is the neatest thing. Come here.
Wow.
Look at that.
Wow. We're pretty high up here. How high above sea level is that?
I don't know, but I saw a benchmark on this topographical map. If we can find that, it's around here somewhere, it'll tell us.
A bench? Oh, great, because I'm exhausted.
No, Tim, a benchmark. See, we can't see the ocean from here, so the government puts in these benchmarks to give the exact altitude. So if we can find it, it'll tell us. It's around here somewhere. Here it is, Tim.
Oh, wow, you're right.
And look, it tells you right on there, we're 3,266 feet above sea level.
That's pretty cool. Can I see the topographical map?
Oh, so now you want to look at the topographical map.
Yeah, well, maybe it's useful after all.
Well, there you see one practical use for a topographical map. And if you're an avid camper, you can use the map to find a level area to pitch your tent, or pitch your tent at an area that's near some water where you can clean up and get supplies, things like that. So there are other uses for the topographical map. And now you've been exposed to that, you might want to practice using one yourself. Now, as far as the global positioning system, they were used by the military for accurate locations, and the U.S. maintains about 24 satellites that give soldiers their position within 15 meters. And before the end of the Cold War, the military actually degraded the signal for civilians so that civilians could measure to an accuracy of only 100 meters. But by comparing that signal to nearby benchmarks, surveyors were able to increase their accuracy to between 1 and 10 meters. And the signal has actually been upgraded. It was upgraded in the spring of 2000. So people with those units now should be able to get a very accurate reading using those 24 satellites. And that is going to wrap up our information for Chapter 1, but you should have completed the chapter review from your textbook already. And what I want to do is take some time to look at, not that review, your parents can grade that for you, but let's look at Activity 1-6 together, and that'll be our little review. It's actually a crossword puzzle, and we'll be going over the clues, and you can just fill that in as we go over each clue. All right, starting with one down. And our clue is a book by Eratosthenes. Book by Eratosthenes. Okay. Two down. Inaccuracy in a map. All right. Three down. Relief color for land below sea level. Land below sea level. That's a little shorter one. Five down. The leading map maker today, and it's just the initials of the leading map maker today. Okay, that should be an easy one. Eight down. Description. This is the suffix for description. Think of the subject that we're studying. Moving on to number 10 down. Detailed land features. Detailed land features. What type of map is going to show detailed land features? $11 down. Mercator's projection. What kind of projection did Mercator have? Okay, if I'm rushing you a little bit, you can always pause the program, but since we're done with the chapter and we're starting into the test here before too long, you should know these pretty quickly by now after completing that chapter review. All right, let's move on to our next one, 13 down. And our clue is cartographer from Flanders. Might be a little harder. But we did talk a good deal about this person. $15 down. Line that divides the northern and southern hemispheres. The line that divides the northern and southern hemispheres. Okay, 16 down. A regular pattern of intersecting lines. A regular pattern of intersecting lines. 17 down. Area, distance, direction, and blank. You might think of the little word that we thought up to help us remember that. $20 down. Author of heliocentric theory. Just his initials. Okay, then we have 21 down. Mercator's map distorts the blank of Antarctica. And then our last one down, 22 down. Earth. What is the prefix meaning Earth? All right, I hope you're doing well so far. We're over halfway done. We're going to go ahead and move over and do the across section. So if you get a word that doesn't fit, you'll know you need to go back and check one of your answers. For across, planar projection. What's another name for that? Six across, blank circle that divides the earth. Almost told you the answer there. What kind of circle divides the earth? Seven across, official American surveyors. What are their initials? Nine across, strip on a globe. Remember, there are several strips put together to make a globe. What are those called? 12 across, map making. Nice long word for a simple task. 14 across, half of the Earth's sphere. And you have half of the answer there. 18 across, 660 feet square. I don't think we talked about that in class, but you should have read about it. And just two more left. 19 across, base meridian in a township. Oh, now we have two more. Okay, two more after this. 23 across, promoted the geocentric theory. Okay, 24 across, this is our last one. Line of latitude. Okay, I hope that you found those fairly easy and thought of the answers quickly. Let's take just a moment to zip over the answers real fast. And we'll just do our downs. Number 1 down, geography. 2 down, distortion. 3 down was blue. Then we went to 5 down from there, U.S. for United States. 8 down is graphy. 10 down is relief. And then 11 down, cylindrical. Then we had 13 down, Mercator. 15 down is the next one. That's equator. Then 18 down is grid. I'm sorry, that's 16 down is grid. And then 17 down is shape. 20 down, NC for Nicholas Copernicus. 21 down, area. And 22 down, geo. Then for our across, number 1 across, azimuthal. I'm sorry, that's 4 across, azimuthal. 6 across, great. 7 across, USGS for United States Geological Survey. 9 across, agore. 12 across, cartography. 14 across, hemisphere. 18 across is an acre. 19 across, principal meridian. 23 across, Ptolemy. And 24 across, parallel. All right, so that way you can make any corrections and bone up on any problems before you start into the test, which is what we're going to be doing right now. And since this is our first one, I'll take just a moment to go over a few things with you, and then you can get started. Okay, starting with multiple choice, be sure to make a special note of any italicized word, read through all of your answers, and then write your answer in the blank. Then on the back, your multiple choice continues. And then at the bottom, you have your short answer. So with these, you'll have a word or phrase to write in the blank as the answer. Then on page 3, you have a matching section. Notice that you have 4 choices and 5 questions. So that means one of those is going to be used more than once. Then you have another matching section. Here are your choices, and then match those up to the correct phrase. At the bottom, you have true, false. Go ahead and write the entire word in the blank so that there's no question there. And as always on true, false, don't overthink. Just take the statement at face value and answer it in that way so you don't trick yourself into a wrong answer. Then your true, false continues on the back. Don't forget to turn the page over. Then you have your essay here. 2 essay questions, mark through that optional. I want you to go ahead and answer these. We've talked about them, and you should be able to answer both of those adequately. Be sure that on your essay you do answer in complete sentences. By 9th grade, that should not be a problem. State your your answer at the beginning, and then support that with details that you've learned throughout the chapter. All right? So now it's time to go ahead and get started with your test. All right, now I'm not going to go over every question on the test, but I do want to take just a moment to look quickly at the essay questions. The first one, why is it difficult to draw a flat map of the Earth? Well, obviously because the Earth is not flat, it's a sphere. And what kinds of distortion are probable? We talked about area, distance, direction, and shape. Then comparing and contrasting Ptolemy and Mercator's maps, lots of things you can put here, just a few highlights. Ptolemy's map was published way earlier in the 2nd century AD. Mercator's not until 1569. Ptolemy did not have a western hemisphere. He exaggerated Asia, but his map was used for over 1,400 years. Mercator did have the western hemisphere. An interesting thing to point out is the lines of latitude and longitude were straight. They were a grid, and that grid is still in use today. Now, we're not going to have time, as you've probably noticed, to do the Chapter 2 preview, so we'll get that in our next lesson. Let's look at our answer to where in the world. Where can you find the country with the greatest number of islands? Did you find out? It is Finland with 179,584 islands. And we won't have a new question today, but I'll see you next time.